Hi everyone, today I'll be showing you how to utilize DESMOS to solve some of the hardest SAT math problems with techniques and strategies and example problems utilizing these techniques. So let's get started. The first thing on SAT math is there are many very difficult geometry problems. These problems usually asking you to solve for something that you don't even have the things to solve for. So what you would use is you'd use a system of equations. A system of equations is something like this, like 2x plus 1 equals y, and then 3y plus 1 equals x. These are two equations with two variables that you can use to solve for the other ones. You can algebraically solve for this, or you can actually plug these into DESMOS and use something called a bracketed regression, so we will actually solve it for you. So example, a bracketed regression looks something like this. There's a bracket, you fill the stuff in it, and then a close bracket, and then use the tilde, and then another bracket, put the stuff in it, and then the close bracket. What goes in this bracket over here is you put this half of the equation. So this half of the equations would go in here, and they'll be separated by a comma. So this right here would be 1, and this would be 2. So you would put 1, 2. And then over here on this side, you would put this half of the equation over here, and you would separate it of what corresponds to 1 first. So 1 is here, which is y. So you do y, x. And then if you plug this into DESMOS, it will actually solve it for you. So if I plug it here, this into DESMOS, I would do like this: the brackets, the tilde, and then the brackets, and then here I would plug in on this side 2x, and whenever you put x or y in a regression, make sure you always put x1 and y1 so DESMOS knows you're making a regression and not graphing. So x1 plus 1, and then comma 3 y1 plus 1, and then on this side over here we put y1 x1, and then here DESMOS will solve it for you. Sometimes in the geometry problems you will have to plug in values of x, so it's true for all values x, but I'll show you that in an example. For this one right here, you don't need to do that. So let's get started with this first example problem here. So this example problem is saying that two identical rectangular prisms each have a height of 90 centimeters. The base of each prism is a square, and the surface area of each prism is k centimeters squared. If the prisms are glued together along a squared base, the resulting prism has a surface area of 92 over 47 k centimeters squared. What is the side length in centimeters of each square base? So this sounds very complicated, but it's actually, once you make the equations, it's not that bad. So let's draw it out first. So a square pyramid would look something like this. Square prism, a rectangular prism would look something like this here with the rectangles, and this is supposed to be a square right here, so just assume that's a square. No, it doesn't look like one, but it is. And then here the height is 90. So what I'm going to do is, because there are two prisms glued on top of each other along the square base, I'm just going to split it like right in the middle right here, and then up here is one prism and up here is the other prism. So I know that the height of each one is 90, so this is 90, and this is 90, and it says it's a square base, so that means that this side and this side are equal. So I'm just going to put S and S to show me that they are the exact same size. So the first thing here is we want to create some equations. So what we can do is we utilize what is given in the problem to make our equations. So first off here, it tells us that the surface area of each prism is k centimeters squared. So just looking at one of these prisms, we know that the surface area is just adding all the areas of all the sides combined. So it would just be the area of this square plus the area of this square plus each of these rectangles. So the area would look something like this. Because these are the exact same, you can just write 2s squared, and that will cover both this square, and then these rectangles, since there's 4 of them, we plus 4. Their height of it is 90, and then S, that is the width of it. So you just basically find the area of each one, and then S. So this is equal to K, which actually will give us our first equation right here. Okay, so then our second equation, what we need to do is, it tells us that the resulting prism has a surface area of 92 over 47 k centimeters squared. So what we can do is we can write that out right here, 92 over 47 k, and then this is equal to, so what we would do is write the surface area equation for this one. So we know that there's the S for the square bases are the exact same. It's S, S, and then S, S. And the amount here are the exact same because these two in the middle are canceled out because they're on top of each other. So it's just 2s squared once again. And then here, all that's happening, it's the same amount. There's still 4 rectangles. It's just the height of them is doubling. So what you can do is here, 4 times 90, this equals 360. You can just double this and 720, or you can just do 4 times 180, which is also 720. So plus 720s. Okay, so this is our second equation that we can use to solve it. And then our third equation that we need to solve for it is that we're basically told in the equation here that the resulting when they're glued together is 92/47, but it says earlier that 1 is k centimeters squared, so 2 rectangular prisms should have the surface area of 2k, not 92/47k. This means that the stuff canceled out, which is these two square things, have a surface area equal to the 2k, which is 94/47, minus the 92/47, and that is equal to 2/47. So we know that 2/47k is equal to 2s squared, which is the surface area of both of these. This here gives us 3 equations that we can now plug into DESMOS to find the value of s. So now we plug into DESMOS. What we need to do is we just write the brackets, a tilde, and then the brackets again. And then on this left-handed equation, we just write this thing on the left side. So this k, 2/47, and 92/47k. So first I'll write k, comma, 2/47, k, so k, comma, and then 92/47/47k. Okay, and then here on this side, we write the stuff on this side. So this, this, and this. So first you write what corresponds with the k, which is the 2s squared plus 4 times 90 times s, and then comma, and then this right here, which corresponds to the 2/47, which is 2s squared, and then finally this over here, which corresponds to 92/47, which is 2s squared plus 720s. So this here now is telling me that the side is equal to 0, but we know that is not true. So what we need to do is we need to define the values of k that can be, and then we know that k can't equal 0. So what we can do is we can just write these curly brackets. They look like this, and write k is greater than 0. K is greater than 1, sorry. This basically just tells DESMOS that it can't equal 0 because we know the surface area does not equal 0. So then when we plug that in, we get that s is equal to 8. So our answer here is B, which is 8. Okay. Now for our next thing. So the next thing is vertex formula. So vertex formula looks like this. It is y equals a times x minus h squared plus k, where h comma k is the vertex. So this can be used to go from this the quadratic form, the quadratic expression right here, y equals ax squared plus bx plus c. It can be used to go from this to here, utilizing the vertex. So if the vertex is given, you always go to this form, and then you could turn it into this form to figure out what a, b, and c are. So another thing here is that when you're doing this, you have to FOIL. So what foiling is that this expands to x minus h times x minus h. So what you do the x times the x, then x times h, then h times x, then h times h. So now one other thing is you need to know basically how the direction of parabolas. So it's based off the value of a. So here a. So if a is greater than 0, the parabola opens up. If a is less than 0, the parabola opens down. So this is important to know, so you know in the problems that ask you to solve for multiple variables that you can actually plug in values of a to solve for it. So now let's get started with this example problem. It says, in the xy plane, a parabola has the vertex at 9, -14 and intersects the x-axis at 2 points. If the equation of the parabola is written in the form y equals ax squared plus bx plus c, where a, b, c are constants, which of the following could be the value of a plus b plus c? So the first thing here is that it gives us the vertex, which is 9, -14. So what we'll do here is just write this in vertex formula. So 9 is equal to h and -14 is equal to k. So I'd write y equals a parentheses x minus 9 squared minus 14. So this is an in vertex formula. Now what it wants us to do is figure out what a, b, and c are. So what we're going to do is we're going to expand this out. So it's going to be in here x minus 9 times x minus 9, and then a, and then minus 14. So this here is a times x squared minus 9x minus 9x plus 81 minus 14. So each of these here have an a next to it, so it's just going to be ax squared minus 18ax plus 81a minus 14. So now we have the equation a plus b. We have a, b, and c. So what we would do is we write out, it's asking us what's a plus b plus c. So what I'm going to do is I'm just going to write out what a, b, and c are. So a here is just a, so it'll be a, plus b here is negative 18a, and then c here is 81a minus 14. So plus 81a minus 14. Okay, so now I'm going to simplify this down. So this becomes 17a right here, and then this becomes minus 17a, and minus 17a plus 81a is 64a. So 64a minus 14. So now if we go back to this problem here, we can see that it's saying that the parabola intersects the x-axis at 2 points. It gives us where the vertex is, so what we can do is draw a little xy plane here, and -14, 9. So that is here, down 14. So that's right about somewhere around here. So what we can see is that if it intersects the x-axis at 2 points, it must open upwards like this. So if it opens upwards like this, as I said earlier, a must be greater than 0. So what we can do here is we can just plug in each of these values here and see which one gives us a value of a that's greater than 0. So what I'm going to do here is I'm just going to start with -12 because that is the smallest value. It makes the most sense that would be right. So I'll go 64a minus 14 equals -12. I plug in, add 14 to each side. 64a equals 2, then a equals 2 over 64. That is a positive number, so now you know that D is correct. And then I can go through C, B, and A, but let me just plug in C real quick, just to show you that if this would equal 14, then you would just add 14 to each side, and that would be 0, and A would equal 0. And if A equals 0, then it's no longer a quadratic, so that can't be right. And all these are bigger, so they would have a negative answer. So that is why D is the correct answer. So another thing you need to know is what the quadratic expression, which was in the last problem we did, ax squared plus bx plus c. So this basically here is just a standard form for the quadratic expression, and it's very useful in helping us find the product and the sum of the solutions. So this problem asks for the product of solutions, and the product of solutions is equal to c over a. This is something you just have to memorize, but this is c and this is a here. So all you need to do is figure out these two things, and then you can just plug that in here and figure out the product of solutions. The sum is negative b over a, which is just this b, make it negative, and then this a. But Those are both very important things you need to know and show up many times on the SAT. So let's get started now with this problem. In the given equation, a and b are positive constants. The product of the solutions to the given equation is KAB, where k is a constant. What is the value of k? So first I can see it gives us this equation, and this here is a, this is b, and this is c. So what I'm going to do first, I'll write out that KAB, it says equal to the product of the solutions. So the product of the solutions I know is c over a. So KAB is equal to c over a. So here I know that c is AB, so is equal to AB, and then I know that a here is 57, so AB over 57 equals KAB. So now what I would do is I would just solve for it. So AB, what I would do is I would multiply AB 1 over AB each side. So 1 times 1 over AB here, and then these would just cancel out, and then this would cancel out, so I'm left with K equals 1 over 57, and that leaves me with A as my answer here. Now on to the next concept here. So one thing on DESMOS is there is a slider thing. So slider, basically you say like x equals 1, and then it will show you a slider at the bottom where you can choose values, and you can slide it all the way down from in any range that you choose. So that'll look something like this. So here if I say x equals 1, then here I put on slider, and this is the slider. So basically it just moves the value of x. So this is very useful when solving equations with a variable, that you can just plug this in and see what the variable is. So another thing is when you're given an equation, say you're given an equation that looks something like this. It's just x plus 2 equals 3. So if you're looking for to write this in DESMOS, you can actually write this y equals x plus 2 and y equals 3, and where these intercept would be the answer. You could just write x plus 2 equals 3 and the same answer of the x equals 1, but this is another way to do it, and this is useful for problems just like this one right here. So this one here is saying that in the given equation, c is a constant. The equation has no real solutions if c is greater than n. What is the least possible value of n? So you know based off this that a here is in front. A is positive. This is a positive value up here. So it must open upward like this. If it opens upward like this and it has no solutions, it must look something similar to this. It must not touch the x-axis, and it must go up. So utilizing this, I can just graph this right here and graph this right here. So y equals 0, then y equals this, and then I can just use a slider for c to see what value of c is true, so these two lines never intersect. So I would just write y equals 0, and then x squared minus 34x plus c, and then it gives me an option to add the slider for c and add a slider. So what I'm going to do, I'm going to zoom out. Now I can see the whole picture. So if I move it this way, you can see that it goes down here, and that's not, you want it to go up. So if I move it this way, it goes up. It just needs to be a much bigger scale. So I'm going to try 100, and see it's still down there. We go 200, still up there, 300. Okay, here now it is above where there's no solutions, but the value of c can still be lower, and it's asking us for where c is greater than n. So n must be the value where it has exactly one solution. So now if I just slowly go down here, I'm at 290. It looks like it's very close. Let me just go 289, and I can see here that there's exactly one solution. So that means that for it to have no solutions, c must be greater than n. So c must be greater than 289 for there to be no solutions. So the answer to this one here is 289. Okay, now for this one. One thing you need to know is what an integer is. So an integer is basically just a whole number constant. So it's whole number. Something like 1 would be an integer. -1 would also be an integer. Like something like 1/2 would not be an integer, so just a whole number constant. That is important for a lot of the problems that ask for integers, so you know that you're looking for something that is a whole number. So now, looking at this problem, the expression 4x squared plus bx minus 45, where b is a constant, can be written as hx plus k times x plus j, where h, k, and j are integer constants. Which of the following must be an integer? So it's basically asking which one is a whole number. So what we can do is giving us this in the form of ax squared plus bx plus c. So what I can do here is I can just expand this out so I'm in the exact same form. So what I would do is I would FOIL it. So I do this times this times the j, and then k times x, and then k times j. So it would give me h of x squared, and then plus hjx plus kx plus kj. So first thing I'm going to do here is, if I look here and I look for b, it says b here, bx, it says b is a constant. It does not tell me that it's an integer. So if it does not tell me it's an integer, b is equivalent to k plus hj, and that is not one of these options. So any one with b in it, I can already eliminate that right away. So these two I can eliminate right off the bat. Next, if I look at a is equal to 4 right here. So 4 is equal to h. That is not any of my options, so I know that it can't have anything to do with a either. So therefore it must have to do with c. So c here is equal to kj. So kj is equal to -45. So now it gives me, in the two answer choices, it gives me h. H has nothing to do with c, so it can't be this one, so it must be d. But to make sure it is, what I would do is I would just multiply by 1 over k each side, and I'll be left with 1 over k, and I'll be left with j equals -45 over k. And here I'm given that h, j, and k are integer constants, so anything equal to j must also be an integer. And even though this here is positive, the negative value of the integer is the negative value of the number is still an integer, meaning that the positive value is also an integer, so this must be d. So that is it. That is all the problems I have. Thank you for watching, and if you have any questions, comment down below and ask them. If you have any suggestions, please comment that too. And don't forget to like and subscribe. Thank you for watching.